Now we're on Chapter 1, Lesson 9, Problem Solving, Multiplication, and Division. Solve the problems below, show your work, in order to perform operations with multi-digit whole numbers and with decimals to hundreds. What we really have to focus on in this lesson are the picture boxes. And by picture boxes, I mean the part whole, in which the total will go on top. And you might have a certain amount of boxes, such as 1, 2, 3, 4. So you might say, here's box 1, box 2, box 3, and box 4. And let's pretend that in each of these boxes, there are 5 pieces of candy. So let's say there are 5 pieces of candy, 5 pieces of candy, 5 pieces of candy, 5 pieces of candy. And you have 4 boxes with 5 pieces of candy each, and you want to know how many pieces of candy do you have altogether. Well, you could see here that X, is what you don't know, is the total pieces of candy for 4 boxes. Now, it's not enough to say X is the total pieces of candy, because you could say total pieces of candy for what? The total pieces of candy for one box is 5. So this is actually the total piece of candy for 4 boxes. So you want to make sure that you're very specific, specifically for what the top is more than anything else. Now that being said, to solve this, you would say, all right, well, in my first box I have 5, and in the next one, and in the next one, and in the next one. So you could add them all up and say 5 plus 5 plus 5 plus 5 equals 20 pieces of candy total for 4 boxes. However, you could have also done, if you look at addition and they're repeating the same number, 5, 5, 5, 5, you can say it's multiplication, because repeated addition is multiplication, and you repeated it 1, 2, 3, 4 times for your 4 boxes. So you could say 5 times 4. The number 5 is being repeated 4 times, and say 5 times 4 equals 20, which again is the pieces of candy. The cool part is if you did know 20, then you could have also done a division problem. Because sometimes, as we saw in the last lesson where we were doing division, it might look like this, 20, and you know that there are 4 boxes, but you don't know how much is in each side of the box, inside each box. And so here's box 1, box 2, box 3, box 4, and your X is the pieces of candy in one box. So this is still, you have 20 total pieces of candy, but this time they're not telling you how much is in each box. And in this case, since you know a total, and you're having 20 and you're getting smaller, you're saying, hey, we're going to divide some up into here, we're going to take some and put in here, then what you're doing in essence is you're doing 20 divided by 4, which equals 5. 4 because there's 4 of them. You could also solve it by subtracting 20 minus 4. And that's like saying that you gave 1 to every single piece, 1 piece to every single box, and you did that once. When you do it once, you have 16 left over, and you do it again, and you're giving every single box another one. Don't forget you have to regroup. And you're doing it again, all the way until you get 0. So what you're doing is you're starting with 20, and what you're saying is, hey, I have 20, here are my 4 boxes, I'm going to give everyone 1 piece of candy. All right, now I have 16. I'm going to give everyone 1 piece of candy. So I did it once, I did it twice. Now I have 12, and I'm going to give everyone 1 piece of candy. And then now I have 8, and I'm going to give everyone 1 piece of candy.
Do you want to eat again?
And then now I have 4, and I'm going to give everyone 1 piece of candy. And at this point, I don't have any more pieces of candy. So I gave everyone equally 5 pieces of candy. And you can tell because I gave 1, 2, 3, 4, 5 pieces of candy. And so you could do repeated subtraction 20 minus 4 minus 4 minus 4 minus 4 minus 4 to see how many times you're able to give some piece of candy for each box. And you could see it's 5 times. Or you could just do the division. 20 divided by 4 equals 5. That being said, knowing how to do these picture boxes and making sure you're very specific will be key to understanding whether we add, subtract, or multiply, divide numbers. Sometimes we'll do more than one step. And so, first off, let's start with number 1, even though they solved it for us, because it's important for us to understand where they're coming from. Number 1, Danny is making punch for a family picnic. She adds 16 fluid ounces of orange juice, 16 fluid ounces of lemon juice, and 8 fluid ounces of lime juice to 64 fluid ounces of water. How many 8 ounces glasses of punch can she fill? So before I even worry about the numbers, before I even worry about adding, subtracting, multiplying, dividing, I need to figure out what's going on in the story. So there's this girl named Danny, and I know she's a girl because they're using the pronoun she. So Danny's making punch for a family picnic. Now punch is a type of a drink, and oftentimes for punch you might have different flavors by combining different things. And so some of the things they're combining 16 fluid ounces of orange juice. So they have some orange juice and they're mixing it in. They're adding 16 fluid ounces of lemon juice. So now we have some lemon juice. So we have some orange and some lemon juice. There's 8 fluid ounces, so a little bit less, of lime juice. And all of that is being added to 64 fluid ounces of water. So I'm imagining this right now. What I'm thinking about is this hole. And in this hole, there's going to be the fruit punch that's all together. So that's what I'm thinking about right now. And I'm thinking about the different pieces. The different pieces are the different types of drinks that they're adding. And so there's a box for each of those. So the first box I'm thinking about is the OJ, the orange juice. The next box I'm thinking about is the lemon juice. The lemon juice. Then I'm thinking about the lime juice. And for lime juice, I'm going to put LI. For this one, I'll put LE. And then last but not least, I'm thinking about the water. And so what's going on in this story so far is that she's making this punch, this fruit punch. And she's doing it by combining orange juice, lemon juice, lime juice, and water. So that's why I have 4 boxes. One box for every type of liquid she's adding. The orange juice, the lemon juice, the lime juice, and the water. Now inside there's different amounts. So she has, how much orange juice does she have? Let's read it again. Danny's making punch for a family picnic. She adds 16 fluid ounces of orange juice. So inside the orange juice, I'm going to put 16 ounces. Then she's adding 16 fluid ounces of lemon juice. 16 ounces of lemon juice. Then she's adding 8 fluid ounces of lime juice. Now she's adding 8 fluid ounces of lime juice. And last but not least, 64 fluid ounces of water. So for my picture box, I'm thinking, all right, she's making this drink. And she's mixing orange juice, lemon juice, lime juice, and water. So those are 4 different types of drinks. So there's 4 different boxes. And I'm putting inside how much she did. 16 ounces of orange juice, 16 ounces of lemon juice, 8 ounces of lime juice, and 64 ounces of water. 1, 2, 3, 4. Now first off, I don't know how much fluid ounces she has total. So once I do something with all these numbers, whether it's add, subtract, multiply, or divide, I'll be able to find the X, which is the total fluid ounces of punch. When you combine the orange juice, the lemon juice, the lime juice, and the water, you make punch instead of just having these 4 separate liquids. So we'll find out the total fluid ounces of the punch when we do something with these. Now, what are we doing with them? here are our options. We could either add, subtract, multiply, or divide these numbers. Well, let's think about it. First off, we have the numbers 16, 16, 8, and 64. Because we have 4 different numbers, nothing is really quite repeating. These two are repeating to some extent, but for the most part, we're probably not going to multiply and divide because there aren't numbers that are repeating. Repeated addition, if all of these numbers were 16, 16, 16, 16, then we could probably either multiply or divide, but they're not. Now next, we have to think, are we adding or subtracting? Well, when we look at these numbers, what are we doing to the orange juice? Are we taking the orange juice and then taking away 16 more ounces, or are we adding to it? And one thing, it says she adds 16 ounces and everything, which is the same as the plus sign, the addition, plus what we're doing is we're combining it. We're doing 16 ounces and 16 more ounces and 8 more ounces and 64 to find the total. Now I don't like adding left to right, so I'm going to rewrite this with my largest number on top, which is the 64. Then I'm going to do the 2 16s. And the trick right here is to make sure that the 8 is lined up with the 1s column. So if you put the 8 in the 10s column, it's going to be wrong. Because this is 8, not 80, you have to put it in the 1s column. Now the reason why I could rearrange them is because of the commutative property of addition, in which you can switch around the add-ins and still get the same, what's the answer to an addition problem? Sum. And still get the same sum. If you want to do 16, 16, 8, 64, that would be perfectly fine as well. You'd still get the same answer. I just changed it up. Now when I add, I think 6 plus 4 is 10, so I know that. 6 plus 8 is 14, so 14 plus 10 is 24. So I'm going to put the 4 here. I'm going to regroup the 2, the 20, into the tens place. And then I'm going to think 2 plus 6 plus 1 plus 1, 6, 7, 8, 9, 10. And so I have 104. Now what's 104? I have 104 total fluid ounces of punch. So this is my total fluid ounces of punch. Now let's see if we answer the question quite yet. Let's see what the question is asking. Danny is making punch for a family picnic. She adds 16 fluid ounces of orange juice, 16 fluid ounces of lemon juice, and 8 fluid ounces of lime juice to 64 fluid ounces of water. So she has a total of 104 fluid ounces. Now the question is asking, how many 8 fluid ounces glasses of punch can she fill? So now they want to do a second step here. Now they're asking, now that you know the total, they want to know how many 8-ounce fluid glasses of punch can she fill. What they're asking now is, all right, she has all this punch. What she wants to do is give each guest 8 fluid ounces, 8 fluid ounces, 8 fluid ounces, 8 fluid ounces. How many people can drink, or how many cups can she fill? So that's what they're asking at this point. So we're going to create a whole new equation in a whole new box. So this time, I know that my total is 104 fluid ounces. So total fluid ounces of punch. Now, what Danny wants to do is have 8-ounce glasses of punch. So one box is going to represent one glass. So this is glass 1, okay, or cup 1. This is glass 2. How many glasses are there? Well, that's what we have to figure out. How many 8-ounce glasses of cups can she fill? That 8 is referring to how much is inside each glass, and you don't know how many glasses there are. So this is your question mark. You don't know. That's what you're trying to find out. But they said how many 8-ounce glasses of punch can she fill? She's saying that this glass is going to have 8 ounces. This glass is going to have 8 ounces. This glass is going to have 8 ounces. So 8 ounces each time. How many glasses can she have? Looking at the total, you have 104, and we can either add, subtract, multiply, or divide these numbers. Now here, because you're not doing 8 plus 8 plus 8 plus 8 in the sense that you don't know how many there are, we're not going to add or multiply. We're not getting bigger here. Right here, we have a total. We have 104 fluid ounces in this huge pitcher. Imagine this huge pitcher. And what we're doing is we're taking away and we're putting 8 ounces. We're pouring in 8 ounces. We're pouring in 8 ounces. So really what we're doing is we're subtracting from the whole pitcher, or we're dividing them up into equal spots. Now we could get crazy and go 104 minus 8. You can see here we're going to regroup quite a few times. You can see I'm using my fingers. That's okay. 14 minus 8 is 6. 96 minus 8. And you can see that this process is going to take a long time. And you might very easily make a mistake. And what you would do is you count how many times did you subtract 8 all the way up until you got to 0. Now you could do that, because what you're doing in essence is you're saying, all right, here's my 104 fluid ounce pitcher. Here's 8 ounces for you, 8 ounces for you, 8 ounces for you, and see how many times can you subtract 8. So far we did it twice. Keep doing that until you get 0 to 0, but that's going to take forever. So repeated subtraction is the same as division. So instead I'm going to divide. I'm going to do 104 divided by 8. And because in 5th grade, in terms of chapter 1-9, I haven't yet taught you how to divide going like this. If you remember this from 4th grade, feel free to use that style. What I'm going to do is take this opportunity to review the lesson prior and do distributive property. 104 divided by 8 is the same as 8 times something equals 104, correct? And we're going to do the distributive property. We have 8 here. And we're going to see 8 times 10 equals 80. 8 times 20, 8 times 2 is 16, plus a 0 is 160. We only have 104. Too much, we'll use 8 times 10. 8 times 10 equals 80. Now, 80 plus this number better equal 104. So, 104 plus what equals 80? And if you don't know, you could do 104 minus 80 equals, regroup, 24. Oh, that's not right. Oh, they should say 80, and this should say 104. Oops. 80 plus what makes 104? And then that's it. That's where the 24 goes. Whoops. Ignore that. But anyway, 24 goes in there. 80 plus 24 will make the 104. Remember, we're doing the 8 times. 8 times what is 24? So 8 times 10 was 80. 80 plus 24 make 104. 8 times what makes 24? 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So this answer is 10 plus 3, which is 13. And so our final answer is 13. We can have 1, 2, 3, we could have 13 glasses of 8-ounce punch. So we can fill 13 glasses, each with 8 ounces. We could have 1, 2, 3, 4, 5, 6, 7, 8. We could have 13 glasses, each with 8 ounces. So you can see here, they did the same exact thing. For the first one, they added just like we did. And for the second one, they used the distributive property to figure out 13 glasses. All right. If I went a little too fast in terms of the distributive property, go ahead and slow it down. But the key part here is that you understand how these picture boxes came about. If you don't understand the picture boxes, you might want to review this video. I'm going to go ahead and go to number 2, so get ready. Okay, now we're going to try number 2. Keep in mind that we really have to concentrate and figure out what is the question asking and where are these numbers coming from so that we know what to do with them. So number 2. Ryan has 9 14-ounce bags of popcorn to repackage and sell at the school fair. A small bag holds 3 ounces. How many small bags can he make? Okay, I'll be honest. When I read that, I kind of was just reading it. I wasn't actually thinking about it. And so it's okay to reread a problem. And that's one of our mathematical practices. Making sense of problem sometimes involves rereading it and making sure you're processing the numbers. I know that in these videos, I kind of make it look easy, but it's okay to have to reread over and over and to slow down and to think about, okay, what do I do next? Don't get frustrated and stuck that like you just look at it and say, oh, I don't know what's going on. I'm not going to do anything with the numbers. Start from something that you do know, okay? Even if the sentence is, I at least know what Ryan is supposed to be doing right now. All right, let's see how that might look like. So I know so far that there's a guy named Ryan and there's something about popcorn, but honestly I have to reread it because I wasn't paying attention. So Ryan has 9 14-ounce bags of popcorn to repackage and sell at the school fair. So first I'm just reading that and I see, even though there's not 2 numbers here, I see a 9 14-ounce bags. And I got to think, what the heck does that mean? Ryan has 9 14-ounce bags of popcorn to repackage and sell at the school fair. So he has this huge amount of popcorn that he's going to repackage and sell. Repackage means he has all this popcorn and he's going to make it into smaller things so that he could sell it to more people. So Ryan has 9 14-ounce bags of popcorn. What that means is he has 9 bags. Okay, this 9 is referring to how much he has. Ryan has 9 14-ounce bags. So first off, I know he has 9 bags of popcorn. This is bag 1. Bag 2. I am not going to draw out 9 boxes of popcorn, but I'm going to say that this is bag 9. So far what I know is Ryan has 9 14-ounce bags of popcorn. Bag 1, bag 2, bag 3, 4, 5, 6, 7, 8, all the way up to 9. What they mean by 9 14-ounce bags, this 9 is referring to how many bags he has. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the 14-ounce means that's how much is inside each bag. Inside this bag is 14 ounces of popcorn. Inside this bag is 14 ounces of popcorn. Inside this bag, there's 14 ounces of popcorn. He has that 19 times. So far, what I know, Ryan has 9 bags of 14 ounces of popcorn. 9 14-ounce bags of popcorn. 9 14-ounce bags of popcorn. And what he's going to do is he's going to repackage and sell it, blah, blah, blah. Before I figure out what to do with the rest, I need to figure out how much popcorn he has altogether. So X is the total popcorn Ryan has. Okay, this is he has to sell altogether. This is all the popcorn Ryan has to sell. And the total is on top, and it's what we're trying to figure out. And what we could do to figure that out is combine the first bag and the second bag and the third, the fourth, the fifth, the sixth, and it's getting bigger. 14, and he has more, and he has more. To get bigger, you could add or you could multiply. So I could either choose to add 14 plus 14 plus 14 plus 14 plus 14 9 times, or I could just actually multiply that out. 14 times 9. And since we've been doing a lot of multiplication, I'm thinking I'm going to use that method. 9 times 4 is 36. The 6 is going to go here. The 3 gets regrouped. 36. 9 times 1 is 9, plus 3 is 9, 10, 11, 12. So we have 126 ounces of total popcorn that Ryan has to sell. Oops, I forgot the 1 in front of 126. He has 126 ounces of popcorn to sell altogether. Now, a small bag holds 3 ounces. So, he's going to repackage these into just 3 ounces. And he's probably just going to sell it like, you know, what we do for like $1. So he has like a small 3 ounce, he sells it for $1. 3 ounces, 3 ounces, 3 ounces. So here's our second part of the equation. We know right now he has a total of 126 ounces of popcorn. So that's your total popcorn to sell. And what he's going to do is he's going to bring them into small bags. So here is bag 1. Here is bag 2. Do you know how many bags he has? A small bag holds 3 ounces. How many small bags can he make? So you're telling me right now you don't know how many bags he needs. So when we need to figure out how many bags. But we do know the small bag, this bag holds 3 ounces. So we're going to have 3 ounces. 3 ounces and sell it probably for $1. 3 ounces. So you have a total popcorn to sell, which is 126. And that's your huge container. And what you're doing is you're going to scoop 3 ounces out. You're going to scoop 3 ounces out. You're going to scoop 3 ounces out. If you're scooping and you're taking away each time, you're getting smaller. So you could either subtract or divide. So if we want to subtract, we could do 126 minus 3. And you're going to see that we're still 123 and we're going to only subtract 3 at a time. Whew, this will take forever. So far, we scooped 3 ounces and we made 1 bag. We scooped another 3 ounces and we made another bag. And we're going to keep doing that until 120 becomes 0 left. I do not want to subtract all the way down until I get to 0. So instead, I'm going to do 126 divided by 3. Again, with the other problem, if you know how to divide 126 divided by 3, knock yourself out. I'm going to go using the distributive property. So this is the same as 3 times something equals 126. 3 going over here. Now, when we multiply this number, we want to get close to 126. So if we do 3 times 10 equals 30, that's not very close to 126. If we do 3 times 20 equals 60, that's not quite close to 126. If we do 3 times 30, 3 times 3 is 9, plus 1 extra 0. That's getting closer, but I think we get even closer. 3 times 40, 3 times 4 is 12, plus 1 extra 0 is 120. That's getting really close, but let's see if we can get even closer. 3 times 5 is 15. With 1 extra 0, that's too much. So you could see when we're doing 3 times a number, 30 is too small, 60 is too small, 90 is too small, 120 is pretty darn close, and then 150 is too much. So we're going to do 3 times 40. 3 times 40 is 120. This number plus this number needs to equal this number. So 120 plus what equals 126, or 126 minus 120 equals 6. So this is 6. Keep in mind, 3 times whatever this is has to equal 126. We already did 3 times 40 equals 120, and then 126 minus 120 is 6 left over. We're still using 3. 3 times what is 6? 3 times 2. So your final answer is 3 times 42 equals 126. 3 times 42 equals 126. Or 126 divided by 3 is 42. So this 42 is referring back to this. He could make 42 boxes, or is it bags or boxes? Bags of 3-ounce popcorn. So, going back to the question, how many small bags can he make? He can make 42 small bags of 3 ounces of popcorn. Altogether, he can make 42. Always keep in mind, what are the numbers asking and what would you do? What's your total? What are you looking for? All of that good stuff. Final answer is he could make 42 bags of 3-ounce popcorn. He can make 42 small bags of 3 ounces of popcorn. Now, good luck with numbers 3, 4, and 5. Slow down. There's multi-steps in, I think, almost every single one of them. And you can do it if you just slow down and reread, just like I did with Ryan. I'll be honest, I didn't even know what 9 14-ounce bags of popcorn meant when I was just reading it to you guys. I had to think. And it takes a while. And this is going to be challenging, which is why you only have 3 problems to do. So give it your all during these 3 problems. And don't be afraid to get frustrated. But after you're frustrated, take a deep breath, reread it, and slowly start to map it out. What's going on? Where did the numbers go? How many boxes are there? What goes inside each box? Why? I do want to do one of the ones on the back, so I don't feel like I'm just ditching you guys completely. So, number 1, I think you can do. So I'm going to do number 2. Stefan plants seeds for 30 carrot plants and 45 beet plants in 5 rows with the same number of seeds in each row. How many seeds are planted in each row? Woo! All right. I got to slow down and figure out what's going on. So we have this person, and I don't know whether it's a boy or girl because it doesn't use a pronoun. So Stefan plants seeds. So, okay, we have this gardener. For 30 carrot plants, so you have 30 carrot plants and 45 beet plants in 5 rows. And there are 5 rows with the same number of seeds in each row. Seeds in each row. How many seeds are planted in each row? Okay, so we have these seeds. There are 5 rows altogether. There are the same amount of seeds in each of the 5 rows. How many seeds are planted in each row? So first off, let's see how many seeds there are altogether. So we have, the first thing we need to do is find the total seeds, total amount of seeds. So we have 2 different types of seeds. We have the carrot seeds. And then here we have the beet plants. Stefan plants seeds for 30 carrot plants. So we have 30 seeds. And 45 beet plants. So we have 45 seeds. And this would be the total seeds planted. Both the carrots and the beet. And what we'll do, since they're 2 different numbers, is we'll either add or subtract. And because we're finding the total seeds planted, we're taking the carrots and the beets and putting them together. We're going to add 30 and 45, which is 75. So we have 75 total seeds planted. Now, with these 75 seeds total, what we're doing is we're putting them into rows of 5. In 5 rows, in 5 rows. So what we're doing is we have 75 seeds total. And what we're doing is we're saying, hey, here's row 1. Here's row 2. Here's row 3. Oops, I don't know why I put a B. Here's row 4. Here is row 5. So we have 5 rows. Each row, there's the same number of seeds in each row. So we don't know how much is in row 1, so that's an X. But we do know row 2 has the same exact amount, so you could put the same letter. We don't know how much is in row 3, but it's the same amount as all the other 5 rows. So what this X represents is the number of seeds in 1 row. So you could see we have 75 seeds. And what we could do is say, hey, let's give 1 seed to every single row. Now we have 70 left. We did it. We gave every seed 1. Every row 1 seed. Now we give another row, every row 1 more seed. And now we have 65 left. So we could keep doing that until we get to 0, but that's going to take a really long time. Instead, I'm going to do 75 divided by 5. And if you know how to divide the way that you probably learned in 4th grade, you could do it that way. If you don't remember that one, I'll teach it to you later, and for now you could just do the distributive property. Or if you just want to challenge yourself and practice the distributive property, because in my opinion, it's a little bit more steps and a little more challenging to some degree, but this is the setup for number 2. Good luck in solving the final answer, and it's a 2-stepper. First, you had to find out how many seeds were planted. Then you had to figure out how many seeds were in one row. Please, please rewatch it. Make sure you're not just copying, but you're actually understanding. There's a difference between doing and understanding, between memorizing and applying, and I really want you to focus on that. All right, have a good day.